Hey everybody, this is Duke with the third video in this build series playlist. In this video we're going to go over the physical construction kind of methods of building this quad out in terms of screws and wires and soldering, that kind of thing. And I hope to give you a good overview. SpeedyBee has some pretty good instructions on their website on how the frame goes together, but of course I'm going to address our specific electronics we have in this video and talk about the all-in-one board and the motors and that kind of thing. So I'm going to try to make this as brief as I can while still showing everything I need to show. And so we're going to start kind of working our way, I think, out towards the center, if that makes sense. So we'll start with the propellers actually and go to motors, and then the flight controller ESC stack in the middle and everything. And I have some of it kind of partially assembled here to try to demonstrate some of that. So with our motors, your motors come in a little box like this. And they'll basically EMAX ships their motors like this. They have kind of a little two-compartment thing here where they have the motor, and it's just kind of blocked by the sticker on the other side, so the motor can fall out if you pull it out really fast or something. So be careful with that. You get your motor, and then the wires coiled up here, and there's a little pack of screws that comes with each motor. And I mentioned that even though we're going from the out in, we're starting with propellers, because some of these screws that come with the motors are actually what you can use for your propellers. And so let's take the flight control off for a second. If you look at our frame, so this is the carbon fiber part of the frame for the SpeedyBee35, and there's lettering and stuff like that. That's going to be the top side of the drone. And then remember, the motors are mounted upside down in the sense it's a pusher. So the motors will mount on this side of the frame. And when you get your motors, when you pull them out of the package from EMAX, they come with a group of screws. So we have like 4 bags of screws they come with. And one of mine, let's see here. There we go. There we go. So 4 bags of screws that come with the motors. And we're going to kind of lay these out here. You have a set of silver screws. You have 2 sets of black screws where there's 5 screws per bag, I believe. And then one little screw here with a little gold looking, looks kind of like a washer. It's like a little bushing in that bag. So let's talk about what those are for, and that'll help us understand propellers a little bit more on this quad. So the silver set of screws is for your propellers. So you can set that aside in terms of motor stuff. We have 2 sets of black screws. We're going to use the set that is shorter to attach our motors to our frame. Okay, so you can set the longer set aside. And then this one here, this other single screw with the bushing is actually a replacement screw, which I think is pretty cool that EMAX actually included that. Let me get my screwdriver here. A replacement bushing, we can actually see it actually through the frame. I didn't realize that. For that screw down there, that screw and that golden bushing right there, those are they're attaching the motor bell to the motor, the stator, basically attaching the 2 halves of the motor together. Okay, and so we're going to pull this off so you can see there that golden washer is the same little bushing thing right here, and then we have a screw there. So the screw and bushing here, you have a replacement for those in this bag. So I'd save that as well just in case you need a replacement. So the last bag remaining is the one that has the shorter set of black screws. Okay, and so we know that those are the screws for our motor. I'm going to put the motor on the arm, which makes it easier to attach the propeller, and we'll talk about the propeller in just a second. So when you're attaching screws to a motor, let's see if we can be able to see this here. You can see the screw sticking out of the frame there. So how do you determine what length of screw to use? Why didn't we use the longer screws, I guess, is a good question. The shorter screws protrude just far enough that if you were to take the motor and kind of lay it on the arm like so, so get it to focus on my hands here. Come on, camera, there we go. It's about the right height to go up through the motor mount, this kind of metallic piece on the bottom of the motor. Not too far, like up into the copper coils. We don't want to go up into the copper and ruin things that way. And we don't want it to only engage the motor in like 1 or 2 threads, because it could come off pretty easy from vibration or impact. So that's about the right length there for the motor, and that's how we decided to use these shorter screws rather than the longer ones, which would likely be much too long for this frame. If you had a thicker arm, thicker carbon fiber, then you need longer screws, of course. But in this case, these shorter screws work pretty good. So we can go ahead and put a screw in here and kind of get things lined up. What I like to do personally is just to put a couple screws in, get things lined up, And then I go back and I put the Loctite on when the motor's already held in place. I don't have to fiddle around moving the motor around and trying to get the Loctite in there and getting everything all over the place. Let me get this other screw in. So put a couple screws into the motor like so. And then we want to make sure on our motor screws, okay, and on the screws we'll talk about later where our flight controller mounts, we use Loctite. What we don't use Loctite on is the propeller screws, okay. So if I'm going to Loctite this here, I'm just going to, after I have my motor in place, I can take a screw out. And, you know, I guess thread locker is the non-brand term for this, but I usually call it Loctite, just kind of used to it that way, I guess. So get your thread locker and apply a little drop here to the end of the screw. Just like, oops, sorry, like that. See that little blue dot there? It's going to get on my finger now, but that's okay. It's a little bit on the end of the screw. That's probably more than I need, but it's hard to do a smaller amount than that with this specific bottle of Loctite. Now we can just put it back in to the motor. We already have the motor lined up and stuff, and we screwed it in and tightened it down nice and snug. So we would do that for all 4 screws eventually. I just have 2 screws in right now for the purposes of this video. But yeah, so we got the motor attached. Now we kind of jump back to the propeller a little bit. I apologize for jumping around a little bit there. But now our motor's attached, it'll be easier to install the propeller. So your propeller will come in a bag like this, and these are kind of hybrid propellers, I guess you could say. So when you pull the propeller out, they may or may not, well, let's pull out one that doesn't have it. Okay, pull the propeller out. One of these is just empty in the middle here, so nothing in there. The other one has the little insert installed. So there should be some of these little clear plastic inserts in the propeller bag with the propellers. And that's made so that this propeller can be mounted on a motor that has a 5mm motor shaft. So actually I have one over here. Let's see, so I can put this on this kind of a motor with a larger motor shaft in the center like that. It would slide on there, okay, like so. Or you can mount it on what's called a T-mount, where these type of motors we have here on our build have a smaller center shaft, and they have some screw holes around the shaft that you screw the prop onto, rather than putting a large nut on the top to tighten down the whole thing. So you want to install the little plastic piece here, and then slide the propeller onto the onto the motor shaft. There we go. So it's going to slide onto that center shaft. Okay, and then you're going to need to line up the 2 holes with 2 of the holes that are on the actual motor itself. So there's 4 to choose from, and you just got to line it up with 2 of them. And then once you have it lined up, let's see if we get this lined up. We're going to grab those screws we set aside earlier, the silver screws that came with our motor. They gave you 3 of them in case you lose one. You grab those silver screws, and those should be just the right length to go down through our propeller into the motor. And so I think I got this lined up okay. Sorry, off camera for a second so I can make sure I got it lined up. Okay, so like that. And then I should be able to just screw this down into the propeller. Nice and snug. No Loctite on the propeller. Just tighten it down. Okay. And of course you put the other screw in there, and you do the same on all 4 motors, and so on and so forth. But that's how you mount the propeller onto the motor, and that's how you mount the motor onto the frame. I'm going to take the propeller back off because we actually don't need to have the propellers on for a long time. And so don't put your propellers on right away. It's going to make things harder for you. And then of course once you start plugging things in, you don't want to be plugging in a battery with propellers on the bench. You know, spin up on accident and cut your finger or worse. So I just wanted to show you how that works with these propellers, and also with the screws that come with your motor, and to know which ones are for which thing. Don't throw all the extra ones away. Keep them. You'll need them for the propellers. All right, let's get the propeller out of here as well. Okay, so that kind of moving outward in, we have our propellers first. We talked about our motor mounting a little bit already. Again, the biggest thing there is, of course, making sure you don't forget to put the Loctite on before you're finally ready to fly. And having the motors mounted will help a lot in the cutting and soldering of the motor wires. Having them secured in their actual location will be a lot better than just having kind of approximated when you start snipping the wires to solder them onto the ESC. But let's move to the center of the frame now for a minute. So of course 1 motor on each arm. In the center of the frame we have all these different holes you can see here, all over the frame in general, but there's a bunch of them here in the center for different types or sizes of flight controllers and ESCs and stuff like that. And if you take a look at the frame here, you'll see it. And also we have, I have pulled up here the SpeedyBee documentation. So this is the SpeedyBee35 frame. And if you go all the way to the bottom of the page, you can click on their manual, this is the manual here. Okay. And this talks about the frame as well. And so we see here on the frame, we have the motor mounting areas, 20 by 20, 25 by 25, 25.5 by 25.25, and 30.5 by 30.5. So those are the typical sizes for FPV type drone electronics, hobby flight controllers, we could say. Ours happens to be 25.5 by 25.5. That's the measurement from center to center of the 4 holes that are in the board itself, the circuit board. And so this kind of shows us which holes we're going to be using, which is great. We're going to go back over to the overhead camera. And so we see a little bit that we're going to be using these 4 holes here to mount our flight controller. So SpeedyBee sends these packets of hardware with the flight controller. There's a little baggie by itself, and then one more little pack here. There should be 3 packs plus a little baggie that's separate when you get all the stuff with your frame. And then we're going to be looking for a specific section of these bags, and we're looking for, let's see, here it is. Get rid of these other ones. If we zoom in, there's a section here that says M2 by 12 by 4 and M2 by 18 by 4. This is for 25.5 by 25.5 all in one, and this is for a 20 by 20 stack. So technically one of these will work. These ones are longer than you need. Okay, they're 18 millimeters long instead of 12 millimeters long. We're going to use the 12 millimeter screws. Those fit great on our all-in-one board with the setup that we're doing. SpeedyBee includes in this little packet both the screws and then some plastic nuts. Now, I don't like using the plastic nuts when I build drones, so I have some metal nuts for you. I'll be giving those to you with your other hardware. I forgot to mention in the first video about that, but I'll be giving you some of those to replace the plastic ones. The other benefit is with the metal nut, you can use Loctite, because again, Loctite does not go on plastic, only on metal. And so we'll take these screws out and we will start installing them in the frame. And so you can see I have a couple of them installed here. Let's see, so this is the front, sorry. So a couple of them installed here. Okay, so 1, 2 there, and then they would put the other 2 here, of course. Now I'll be giving you the metal nut, and what we want to do, I don't know that they really cover this in the SpeedyBee manual per se. We're going to be installing a nut on the bottom of the screw, then putting the flight controller on, then putting a nut on top of the flight controller. So we'll have 2 nuts on each screw, one on top and one below the flight controller. And the reason for that is because if we put a nut on the bottom and tighten it down with Loctite and everything, it will create a nice rigid mount point for the flight controller to be sitting on, so it's not wobbling excessively or things like that cause problems in flight. So when you put one of these through, let's go ahead and take, I think it's this one that I didn't Loctite yet. Okay. So you'll thread the screw through, okay, and put it on the other side. And when you get the nut down to, close-ish to the carbon fiber, but not all the way down, we're going to take our Loctite, kind of like we did before, and we're going to put just a little dot, try and get as close to the carbon as we can, and so that the nut will tighten and go through that Loctite as we tighten it. So we're going to grab a little bit of Loctite there. You can kind of see that little teeny drop there, and we tighten this down. Now you'd use a tool, of course I'm just using my finger right now. We use a little wrench to tighten this. And then we go ahead and we have a wrench where my fingers are at, and our screwdriver on the other side, and we just cinch it down a little bit so it's nice and snug, and it's not going anywhere. So now we have a nice rigid mount point for our flight controller. We do that on all 4 corners, of course, of the flight controller. You can clean some of this residue off if you want to. I know it kind of makes the carbon fiber look messy. That's some of the Loctite residue. But we'll go ahead and mount all 4 of those screws and nuts is what you would do. And then we have our flight controller. And let's make sure I put this in the right way here. Okay, our flight controller is going to be mounted. Little arrow is facing forward. Now I realize this is kind of going to be upside down, if that makes sense. Once we flip the quad over, because the quad's a pusher, so it'd be like this. But that's okay. We can change the orientation of the flight controller in the software. I found that this orientation seems to work best for all the stuff we need to plug in. You're welcome to try something else if you want, but that's what I'll be using in this video. Once we have the flight controller down, if we had all 4 screws in and everything. And we're going to kind of dry fit things first, so we make sure everything's fitting before we put Loctite on everything. But you can take the other 4 nuts, and you would take them and screw them onto the motor or the shaft of the screws here. So I'll get that started there. So that would screw down, okay, and we would tighten that down there. You would have Loctite on this thread as well. Before you put the nut on, you put some Loctite on, tighten it down a little bit. You don't want to compress the gummy, the black kind of squishy piece here, too much. You don't want to tighten it down so much that it's pancakes out there. That's too much. You also don't want to have it so loose that it's not really compressed at all. You just want a little bit of compression on the gummy so it's kind of held in place firmly, but not too rigidly. The gummy is supposed to dampen some of the vibrations and things that happen on the copter. So again, throw some Loctite onto the screw. You grab the nut and tighten that down, okay? So it's nice and snug, but not too tight. And then you have your flight controller mounted. That's great. That's good. One of the steps really important to get our motor wires correct is to have the flight controller mounted so we can then measure how long the motor wires need to be. So once our flight controller is mounted and in place where it's going to be its end result, we're going to take our motor wires and we're going to kind of measure how long we need to cut these. Right? You can't just solder them on like this, have all that slack. It's going to get chopped up in the propeller pretty easily, of course, and it looks really messy. So what we want to do is we want to take our wires and stretch them out to the pads here, and we don't want to have it like a tight like that. We don't want that. We want to have some slack, a little bit of slack. So we want the motor wires to more or less lay on the frame, and then they come up to the pads. Okay, so more or less kind of like that. You can throw a zip tie around this if you need to hold the motor wires down if they're a little bit too loose. But I'd rather err on the side of a little bit too loose than too tight, because then I got to lengthen the wires, and that's kind of a pain. So I'm going to go ahead and measure the wires out, kind of push my finger against them to give a little bit of that vertical length there. And then I put my finger right here or so, and I'd probably snip the wires a little bit longer there so I can strip them back and tin them and everything, and then we'd attach them to the pads of the flight controller there, 1, 2, 3, those smaller pads. So that's how you get the motor wire length correct. So you can kind of see here on the constructed version of this, we have our motor wires coming in, and they go up to the 3 pads there. We have in a vertical orientation. These are castellated pads. You can solder them, the wires in at a vertical orientation there, and we see the same on all 4 corners of those pads. Okay. There we go. So there's our propellers, motors, flight controller with motors attached to the ESC. And then we're going to talk about our battery lead and capacitor for a second. So these will come with your assortment of wires and cables and stuff with your flight controller. We have the battery lead and the capacitor. And what I ended up doing on mine, and you may try a different method, but this seemed to work the best on mine, is I had the battery lead attached on kind of the underside of the pads. So of these, let me take this little nut off here so I can flip the flight controller over. I had the battery lead attached on the underside of these 2 pads, positive and negative here, okay? And make sure you look at the label. I'm probably showing you wrong right now. We got negative on, oh, that was right. Okay, so negative on this side, positive on this side. And on the underside, and then I put the capacitor on the top, okay? And part of that was to make sure things would fit. It's gonna be a little bit hard to see here, but the injection molded frame has little cutouts for each arm, kind of so the motor wires can get through from the middle to the motor. And so the capacitor, in my case, I had it soldered on top and then kind of angled in, so that way it could clear the cutout there and not, be squished by the injection molded piece or in the way or something. It seemed to just kind of fit right there. That worked pretty good. You might try a different way, but that worked for me. So I did the motor or the battery plug wires on the bottom side here, and then the capacitor on the top. And the way the motor or the battery lead routes, oops, put this back down there. It's going to end up routing kind of out through here, okay, and then into under the the flight controller like so. And that way, when you have your quad at the end, your battery is going to sit up here, and then you just plug your battery in. Okay. Now remember, we're going to be using batteries with XT60s probably in class because we're using bigger batteries just to get some more hover flight time. So if you want to swap this out for an XT60 now, or you want to make an adapter, or whatever you want to do, just be aware of that. You probably need an XT60 for the batteries we're going to use for these in class rather than an XT30. So for what that's worth. Okay, so there's our attachment there. And then with the capacitor, when you look at a capacitor, there is a side that has a little hash mark on it. And then also if you look at the legs, the two legs, there's one that's shorter. The shorter leg with the hash mark is the negative, and the other side is positive. So when you attach the capacitor, make sure you attach it appropriately so we have negative and positive in the right spots. And you can offset a little bit so it kind of comes out here on off the arm, sort of that little cutout from the injection molding. And same thing with the battery lead here. You might not want to solder it perfectly straight. You might want to have a little bit of an angle because eventually it's going to kind of loop out through this hole, and having it already be going that direction would be better than having it stick straight out, be too stiff, then you have to kind of bend it over a lot to get it to go through the hole here. Okay. So we have our motor wires, our battery capacitor, our flight controller mounting, all that set. Okay. The next section here is a little bit more detailed, I guess you'd say. We're talking about our GPS and our receiver in this case. And so make sure you don't throw any of the wire cables and stuff away from your kit, of course, before you finish anything. There are a couple cables that come with the flight controller that you want to keep. There's a cable that comes with the GPS you're going to want to keep. We're going to talk about how we use those right now. So our Walksnail GPS, if we look at it up close, okay, has a little label right here along the bottom. There's 6 abbreviations: TX, RX, ground for GND, 5V, 5 volt, SCL and SDA is for clock and data, if I remember right, for I2C. So we have our TX and RX from the GPS. We have ground and 5 volt to power this whole thing. And then we have SCL and SDA, which are for our compass, or magnetometer that's built into this module. So that's why we have 6 wires there. And we're going to need to connect this to our flight controller somehow so we can fly with GPS flight modes and that kind of thing. And so if we look at this label, we have these 6 wires coming out here, and those correspond to the label here. So for example, the gray wire is our TX wire. The white wire, which I think is next, sorry, I'm going to spread these out a little bit. The white wire, there we go. Okay, sorry about that. The white wire is our RX. We have black for ground, red for 5 volt, blue for SCL, and green for SDA. So those wires are all present there, and each wire has a color. And so when we start trying to connect this to our flight controller, we want to know which color goes where in the plug. The plugs on these, let me move this for just a second here. So the plugs on these GPS and on the flight controller in this case, if I remember right, I think they're called JST-SH connectors, and they're okay. There's better connectors out there, but they're okay. And we can see on the left-hand side I have the GPS, okay, and then on the right-hand side I have the plug that came with the GPS. And if you look inside the connector, you can see there's pins along the top side or the top of the screen on the GPS. And on my connector there are little cavities or I guess holes to receive those pins on the top side. So you plug this together, it's important to make sure you're matching it up. I shouldn't plug it in like this, because that would be on the wrong side. It wouldn't plug in if you tried to force feed break stuff. Make sure they're in the right direction, in the right orientation, and that you're plugging in correctly. Okay. So if I'm going to plug this in here, I'm going to make sure it lines up, make sure it's nice and straight. Okay. And then I can plug it in. Now I'm going to put my thumb on the back side of the connector to give it a little bit of reinforcement as I'm pushing against it. You don't want to push too hard and break off the connector on the GPS. That would be a big bummer. Okay, we're going to push this in a little bit, kind of just work it in there. The connector will not seat maybe as far as you think it should. A little bit offset there. But it'll go in about, let's see, that one's still a little bit offset. Off to one side, there we go. It'll go in about that far. That's fully installed, fully seated connector. Okay, so it doesn't go in farther than that. Don't keep pushing it in. That's as far as it goes. And that's how you would use these connectors. So on the other side, we have the same connector. We're going to want to say, how do we plug this into our flight control? Where do we plug it in? What are we doing? Okay, so if we go over to the documentation for the flight controller, okay, We have here on the MicoAir website the flight controller pulled up, and the ports tab here, there's different tabs for different things. The ports tab has some information about these different plugs and what they're for. And you can do this multiple ways. The way I'm doing it and recommending you do it, so you can just follow along with me, is we're going to be using this port right here where it says GPS for our GPS. And that makes it a little bit easy to remember. And we can see here that it has these 6 markings for each of the 6 pins. And so what we want to make sure before we plug something in is that we have the wires in the right spots. And unfortunately, different manufacturers do things differently. There's not like a standardized layout that I'm aware of, at least not industry-wide. MicoAir has a pin out here that is different from what we have on our GPS. So how do we fix that, right? How do we get the wires to go to the right spot? We're going to have to do some repinning and depinning, or depinning and repinning of the connector. There's one thing I want to point out right here off the bat. Whenever you're using devices with flight controllers that are serial devices, and that you can tell they are a serial device when they have an RX and a TX, you need to make sure you cross or kind of crisscross the RX and TX. So if I have an RX3 right here, my TX pad for my GPS needs to plug into the RX pad on the flight controller, and vice versa. My RX pad from my GPS needs to plug into my TX on the flight controller. And that's because TX and RX are transmit and receive. So when the flight controller transmits here on TX, it needs to be transmitting to an RX pad on the GPS, and vice versa. When the GPS wants to transmit, it needs to transmit to a receive pad on the flight controller. So the TX and RX get swapped. Everything else, at least in this example here, is going to be straight across. So ground will go to ground, 5 volt goes to 5 volt, SCL goes to SCL, and SDA goes to SDA. So just be aware of that, and you can have this diagram pulled up while you're doing this to make sure you reference it. The GPS itself has a label on it, which is pretty nice. Okay, but if we look at this on our GPS, we can see we have 5 volt and ground in the middle, and you see the black and red wires there. So right away, that's in the middle, right? And on our pin out here, it's on the side. So we know the pin out is not the same, like right off the bat. That's a pretty easy tell. If you look at the other wires as well, they're also not in the right spots. But 5 volt and ground is the one that's gonna fry stuff if you plug it in and it's not in the right spot. The other wires shouldn't damage anything, but it won't communicate properly. So how do we fix that? We've got to repin the harness basically. And so to do that, I'm going to zoom out a little bit here. I'm going to use this little cutoff harness instead of doing the real thing here, since this is going to be somebody's kit. And we're going to talk about how to repin and depin these. So if you look really closely, you might be able to see there's little plastic tabs or plastic fingers. There's 8 of them there, and then right above them there is the silvery kind of gleam of the pins. And each one of those pins is, of course, attached to a wire. We have 8 wires here, 8 tabs, 8 pins. So if I want to change the order of these wires or move them around, I need to remove them from the plastic connector, put them in the order I want, and then put them back in the connector. And so the way to do that, at least the way that I'm aware of to do that, if you already have the connector, you just want to repin it, you don't want to make a new connector, you can remove the wires and put them in the right spots. So I'd recommend getting like an X-Acto knife or maybe a really small flat-bladed screwdriver, something that's small and flat. We're going to need to pry up on one of these little plastic tabs. Okay, the way this works is there's a little barb or hook on each pin, and once you install it, the hook engages with the plastic finger and it can't pull out unless you raise the finger up and then it slides out. So I'm going to try to do this on camera. It's kind of hard to not block the camera with my hat or my head here. But let's go ahead and give it a try. So I'm going to try this green wire here and try to remove that. So it's the 4th wire in, so 1, 2, 3, 4. We count the little fingers here, 1, 2, 3, 4. We're going to go ahead and pry up on that tab a little bit. We don't want to go crazy because we don't want to break the tab off. But once we pry up on that a little bit, 1, 2, 3, 4, we hopefully can get under it enough to release that little hook or barb on the pin, and that will allow us to pull the wire out. If we can do that, there we go, successfully. Hopefully I got that kind of on camera. Prying up there, and then it slides out. We get the wire out, If you look at the side here, and you might be able to see it, sometimes the tab will be a little bit bent up. I'm going to try avoid bending the plastic as much as possible. And we have our wire released. So if I were to do multiple of these, then I could, of course, change their position, and I would then reinstall them. Well, we have this out. Let's take a look real quick. Let's see if we can see this. So facing on the bottom, toward the bottom of the screen right now, they're like a little metallic looking rectangle on the pin. That little rectangle, there's actually two of them next to each other, is what kind of receives the male pin, okay, as it plugs in. If I can show this correctly here. It's going to receive the male pin from the connector as it gets plugged into those two tabs. Okay, it slides in there and then it makes a connection. So that's on the bottom side of the screen right now, those metallic rectangles. Opposite that, so on the top of the pin, there's a little barb, and you can barely see it kind of glint there at the top. There's a little barb there at the top of the pin, and that little barb is what engages the plastic fingers in the connector. So when I'm reinstalling a pin, okay, I need to make sure that I have the little barb facing the right side. So in this case, the fingers, the little plastic tabs are facing up, so the barb is facing up, and then just slide the pin into the position I want it to be in. And if you're lucky, you kind of push it in, it clicks in right away. You might have to finagle with it a little bit. I want to make sure it gets all the way seated and that the plastic tabs are not bent up. And if you get it in there correctly, you should see the little bit of glint of the metal there in the position it's in. And then if you give it a little tug test, so trying to pull the wire out, not super hard, but a decent amount of force, it shouldn't just pop out. It should go in and stay in. That's what we want it to do, right? Okay, so that's how you would depin and repin a connector. And in our case, we need to do that because, like we mentioned a minute ago, our GPS pinout, or the order in which the wires come here, which is how they follow the connector over, right? So the same order is present on the other end of the connector. That order is not correct for how the flight controller is wired. So we need to repin and depin some of those so that when we plug it in the correct orientation, the wires are in the right order, which is what we were looking at a second ago on this page here. Okay, ground, 5 volt, TX, RX, SCL, and SDA. Again, a reminder that when you repin it, you want the TX from the GPS to go to the RX on the flight controller, and the RX on the GPS to go to the TX on the flight controller. Everything else goes straight across, ground to ground, 5 volt to 5 volt, SCL to SCL, and SDA to SDA. So I know I'm saying that a lot of times just because it's one of the most common mistakes when you're doing this kind of thing is not crossing the TX and RX over, and then it won't talk to your GPS, and you can't figure out why. I know it's because the wires are in the wrong spot, so it's not communicating. All right, so there's our receiver, our GPS wiring on the top side of the flight controller and the way we've been looking at it. And if we scroll down here to the bottom diagram, we have another connector on the bottom side. So this one right here is directly below this one right here. So on the bottom side of the flight controller, let's go over to the camera again. If we were to take it off, so right below this one, we see this one. That's the one we're going to use for our receiver and plug our receiver in there. Okay, it is a 6-pin harness or connector as well, and we don't have 6 pins on our receiver. We only have 4, but that's okay. Let's talk about how we're going to do that. So let's grab our receiver. In this case, I just have the small one for an example. Again, I'd recommend one with an external antenna if you can find one like that. And we have these 4 pads here. 1, 2, 3, 4. Ignore this kind of 5th one up here. That's a boot pad, but the first 4 on the bottom here, and your receiver will have your pads labeled hopefully as well. In this case, they're labeled on the back, but it's really hard to see, especially on the camera. We should have a 5 volt, a ground, a TX, and an RX pad. And so this is our receiver wiring from the receiver to the flight controller. It's going to go into this connector. So with our MicoAir flight controller, we had a handful of cables that came with the flight controller itself, along with the battery lead and the capacitor, all the kind of accessory wires that come with the flight controller. And so a couple of these are 6-pin connectors, and then we have one 4-pin connector. Okay. Now I'm not actually sure. It may be possible to plug the 4-pin into the 6-pin connector on the flight controller, which is fine if you want to do that. But when I built mine originally, I just used one of the 6-pin connectors, and I removed 2 of the wires. And so again, when we're doing this, we want to follow the same kind of process. We're going to take a look at the connector here. I'm going to go over and look at it in the diagram. And we see that from left to right here, we have RX, TX, RX, TX, 5 volt and ground. I just used RX and TX1. I left RX6 and TX6 unpopulated, so I took the wires out of those 2 and just left these 4 grouped together here. And I just did that because I wanted to make them all together, I guess, instead of having a gap in the middle. I would recommend doing it that way in class just because then you'll be able to follow along with how I built mine more readily. So we're going to remove TX6 and RX6 and leave the other 4 wires in there. And if we're doing that on our harness itself, okay, we're going to grab our harness. We're going to figure out which way it plugs in to our flight controller. Okay, so we're going to look at those pins and the connector and everything. Focus there. In this case, the pins are kind of towards the camera right now, so the connector is going to plug in like so. Make sure I got this right before I mess something up. Yeah. Okay. Plug in like so. And again, you want to push it in with reinforcing a little bit with your finger so you don't bust the connector off on accident. But it's a pretty snug fit, honestly. So you got to be careful. And that's about fully installed right there. Okay. And we have our wires. Okay. And so we say, okay, well, I'm going to take out the 2 wires for TX6 and RX6. In this case, that would be the blue and the yellow wires. Okay. Take those ones out. Oops, not blue and yellow, sorry. Blue and white, my mistake. Blue and white wires, take those 2 out. I will leave the other 4 in there. Yellow, green, red, and black. Okay, so to get those wires out, you're just going to take the connector back out. You don't even have to plug it in all the way in the first place. Of course, you just line it up correctly. You take it out, depin the blue and white wires out of this side of the connector, and then you just have the 4 wires left. And on the other side of the wire harness, on the other side here, most receivers aren't going to have a plug. If you have a plug, then you can use that, of course. Most receivers are going to be direct solder. And so you would snip off the end here and then just solder those wires appropriately to your receiver. Remembering again that the RX here needs to go to the TX pad here. And the TX here needs to go to the RX pad here. And then of course 5 volt and ground just go straight across. 5 volt receiver to 5 volt flight controller. Ground receiver to ground flight controller. Okay, so just remember that crisscross for RX and TX, depin the 2 extra wires, and there you go. One thing you might want to start thinking about a little bit as you're, since this wire harness is one we're going to cut. Let me see here, get this mounted back on here. The GPS has plugs on both ends, so you might just leave that the default length. Oops. You might leave that the default length when you connect it up. You can see here my GPS. Let's move this a little bit. On my finished build here, my GPS is right up under this yellow thing, so the wires kind of come down and snake into this central compartment. And they've got a bit of a bundle here. We don't need quite that much wire, but it's fine. It's not too much. However, on the other hand, my receiver, I wasn't sure where I was going to mount it, and I wired it up, and it had a lot of extra wire. So as you start doing your receiver wiring, where you're going to cut one of the ends off the connectors, or cut one of the connectors off the wire, you may want to cut it longer or shorter depending on where your receiver is going to go on the frame. Mine was tucked kind of in the back over here, and so you really only need maybe cut this in half. That's plenty of length. You want to twist the wires in the end so they stay bundled, so it takes a little bit more length when you twist, but you don't need this whole wire length to be just connected to the receiver right back here. It's way too much wire. You don't need that much. Okay, so think about that as you're deciding where to cut this at. Give yourself some slack so it's not too tight, but don't leave a bunch of extra wire if you don't have to. It just looks more messy and adds a little bit of weight. Okay, so that's how we're going to do our receiver wiring from the port on the bottom side, again, here, to our receiver. Okay, and that should give us what we need for our receiver and our GPS. So I think that should accurately portray the specific details for our build compared to the default SpeedyBee build, where they have the let's see, the manual here. They kind of talk about where the screws go and stuff like that, which is all the same for our build. But I wanted to specifically address our flight controller, our electronics, where they might go. But if you follow along here, you'll see they talk about installing different things. Now, anything related to a VTX, we're not going to use, or a video transmitter, we're not going to use video transmitter, so don't worry about that. But we can see they start to put the frame screws in. And if you just look, M3 14 millimeter, look at the little packs of screws you have, and one of them will say M3 by 14. You go, oh, that's the screws I'm supposed to use. So that's pretty straightforward. Same thing here. Once you start putting the battery plate on, they give you the screw types and stuff. The documentation is pretty good for building the frame out here. And there's your antenna in the back, kind of like I showed you, and so on and so forth. We won't use every single piece. Like we won't use necessarily the camera mount, so you don't have to install that. But you'll start to get the hang of it as you go through the guide. And then of course this video is meant to help you with the soldering and wiring and stuff as well. So I hope that gives you a good idea. I'll make sure I put the links for these documents in the video description so you can find them, as well as the assignment and stuff. That should about do it. Oh, sorry, one more thing. I almost forgot. Okay, this little nifty USB extension board thing that they give you in the SpeedyBee frame. So on the actual completed build here, okay, if we flip it over, here's our, let's zoom out a little bit. Here's our battery in the back, and there's this little nice handy USB port right there that can plug into to connect to the computer. And that's pretty nice, because otherwise, I don't know how I'd get the USB port in here because it's buried inside the frame. It'd just be next to impossible. You have to take the whole thing apart just to connect to the computer, which is kind of a nightmare. So SpeedyBee gives you this little attachment method here, and the way it works. Let's pull this apart. Sorry, I plugged it in earlier, and now I want to show you the different sides, but it's being a little bit stubborn. Okay, there we go. So they'll give you this piece in the 3D printed bag of 3D printed parts. Okay, it'll come in the bag there, and it comes with a couple of these adapters. So we have two adapters here. So you have a USB-C in my left hand, and then a micro USB in my right hand. Now, luckily, our flight controller is USB-C, so we have one of the two options. So you can save this for something else, or just put it away, or whatever. I don't know what else to use that for in our case. But the USB-C connection is pretty slick. So we'll just plug this in. You can do this kind of at the end of your build. You don't have to do it right away. We'll plug this into our flight controller, okay, into the USB-C port. And then this little piece here ends up kind of getting installed into the back of the frame, kind of like this. So when you flip it over, it looks like my completed quad did, as a little USB port on the back. But this little piece has installed a USB-C into it with the little wire harness here, and these plug together. Let's see here, make sure I get the right orientation, and they would plug together like so. And then you have a extended USB connection to your flight controller from outside the drone. You don't have to take the thing apart to get to the USB connection, which is really nice. And so there's that connection there. So that's the last thing we need to connect to our flight controller, besides all the other wiring we talked about and soldering and so forth. So that's the last piece there. All right. Okay, I think that should cover everything. Let me know if you have any questions, of course, and I hope this helps with your SpeedyBee35 MicoAir build. Thanks.